Hey everybody, welcome to another week. We are on the week with the Kaplan-Meier survivability curves. This is one of my, honestly, most favorite weeks. I really enjoy um, survival curves and survival probabilities and all the statistics that go on behind this type of analysis. So the Kaplan-Meier method is a non-parametric method used to estimate the probability of a group in their survival given prior information. A lot of the times, Kaplan-Meier is used with in healthcare. For example, determining time to failure for knee replacements, studying the effects of drug doses on cancer survival in rats, a lot of point in time and survival types of analyses. One of the most important points with the Kaplan-Meier is something called censored cases. Censored cases are important because there are people that will be in your data set that don't experience the event before the end of your study or observation period. So the Kaplan-Meier method is one of a few different approaches that can incorporate the censored cases directly into the analysis, which is a very interesting approach. The Kaplan-Meier method is really kind of just taking every point that you have data for. The Kaplan-Meier method will estimate the probability of surviving or not experiencing the event, which we'll kind of see the difference between experiencing and not experiencing the event. It's all based on your data when we start to look at it in a particular point in time with consideration of the censored cases that are in your data set. So this week we are looking at something called the Healthy Hearts Initiative at Hospital USA. There we are. So you are the CEO of New England Regional Healthcare Group, and you recently read a case study about something called the Healthy Hearts Initiative at Hospital USA. And Hospital USA, given the Healthy Hearts Initiative, was able to see significant changes in myocardial infarction patients who actually participated in this initiative in comparison to the patients who opted out. In the case study, Hospital USA published and made available their de-identified dataset, which contains the results from their Healthy Hearts Initiative. The Chief Medical Officer of your healthcare group also has read the same case study and has been fielding interest in starting a similar type of initiative for MI patients at your hospital. So I have provided you that Healthy Hearts Initiative dataset, and we are going to take a look at a couple of different questions pertaining to that dataset in this assignment. As I mentioned a few weeks back, these recordings will get shorter and shorter as we work through different statistical analyses and tests, but I still will provide you a hints and information page in your assignment. So in this recording, I am just going to cover the Kaplan-Meier analysis and looking at the summary, the SPSS output, because if I scroll to the third page of the assignment here, we have done all of this already in prior weeks, all the way up until the Kaplan-Meier survivability analysis. So, as I mentioned, we have already looked at frequency tables, crosstabs, comparing means, determining normalcy, and the independent sample t-test and the Mann-Whitney-U non-parametric test last week, calculating differences from means, again, the Mann-Whitney-U. So this recording, again, is just going to cover the Kaplan-Meier survivability analysis. So I have already loaded a random sampling of your data into my SPSS. So in my data set, I only have roughly 1,225 patients. In your data set, you have just about 3,000 patients. So running the Kaplan-Meier survivability analysis only takes a couple of quick steps. Once you have actually taken a look and kind of understand your data set a little bit more. So in our data set, we have our gender variable, 0 for male, 1 for female. We have the total cost, which is a variable view here. We have the total cost of all of the patient's healthcare in calendar year 2018. We have the patient's Charleston score, the days until readmission, the mean length of stay for all of their hospitalizations in calendar year 2018, an indicator if they were participating in the Healthy Hearts Initiative or if they were not. And then we have an indicator if they survived all the way through calendar year 2018. So again, these binary variables, 0 being false, 1 being true, so we will have an indicator of 1 if they participated in the Healthy Hearts Initiative, and then we have a value of 1 here for patients who survived the all the way through calendar year 2018. If you look at the assignment that I gave you, I put a quick note at the bottom that I have already censored your data for you. So all of the data has already been censored to contain only patients who reached the end of the initiative. Therefore, all of the values for Survive 2018 will equal 1. All right. So let's hop right into actually running the Kaplan-Meier. So the Kaplan-Meier will be in Analyze and Survival, and we're going to run the Kaplan-Meier here for us to see. So we have a couple of fields that we need to fill in some required information for. The first one is the time factor. So what is the time factor that we're interested in studying in our assignment here? And that would be the days until readmission for the patients who participated in the Healthy Hearts Initiative and the patients that didn't. So I will take my days until readmission variable, bring that up to my time. And then the next one is the status of the patients at the end of the initiative, or at the end of the time span of the Kaplan-Meier. In that situation, that would be our censored variable for Survive 2018. So I'm going to go ahead and bring that up to here. And my defining event for the Survive 2018 is a single value. So I am indicating a value. I should bring that over here so you can see it. I'm indicating a value of 1 in this variable, that this is the value indicating that the event has occurred, so that they have survived all the way through calendar year 2018. Continue, and we'll see that that now fills in to here. Next up is the factor variable, and the factor variable is the variable that we use to define membership or some kind of striation between the two groups. And what we're interested in looking at here in the survivability analysis is the difference between the patients who have participated in the Healthy Hearts Initiative and the patients who did not. So what we're going to do for this one is take our initiative participant variable, or the HH initiative, and bring that down to our factor. The strata and the labeling cases by we're not going to use here, so we can just ignore those for right now. But one thing that we do need to do, so that way we can get the right tables at the end of our analysis, is open up this compare factor window. And the factor that we are interested in is the log rank test statistic, and we'll discuss that when we're actually looking at the results of our analysis. So just go ahead and enable that log rank and click continue. Lastly, the two pieces of information that is most important for our output from this survivability analysis is found in the options menu. So in the options menu, you're going to want the survival table, which is just, it's going to be a giant table, but it is something interesting to look at. And then the mean and median survival, which will, in the end, give us our mean days of readmission back to the hospital for the patients who participated in the initiative and the patients who didn't. And lastly, we are going to want our survival plot. So go ahead and check that one and click continue. All right, so now that we have all of our pieces of the Kaplan-Meier set up correctly and appropriately, let's go ahead and actually run that analysis by just clicking OK. Move my output over here. All right, so the first table is the case processing summary. We have this in the majority of our SPSS output, but in this situation, one of the important pieces of information here is this censored percentage. The censored percentage is important because we need to make sure to meet one of the assumptions of the Kaplan-Meier test that we have a similar number of participants or cases in each of the two groups actually being censored. And in this situation, because we have already pre-censored the data, none of the cases or initiative participants have been censored. So we see that all of these values are 0. So next up is our survival table. The survival table shows each participant and non-participant and the number of days before their next cardiac related hospital admission. In this analysis really isn't overly important because I'm not asking you to report on specific participants, just everyone as a whole. Sorry about that little interruption there. So as I was saying, the survival table, for the purposes of what we're looking at, because I'm not asking for specific initiative participants and information on them, the survival table in and of itself is not particularly, very important in this situation here. The one that is of most importance is going to be the means and median for survival table that we have here. So this is going to show you the mean number of days to readmission for the participants and non-participants. And for the purposes of the question that we are trying to answer, we will be interested in the mean, mean values here in the middle here. And we can see that in my data set, people who did not participate in the initiative, they had a mean number of days to readmission of about 129, whereas people who did participate in the initiative had a mean number of days to readmission equaling 182. So that is a fairly significant difference to look at from without looking at the log rank, the Mantel-Cox test. But let's look at that table next. The actual test of significance between the two groups here, again called the Mantel-Cox test, is showing us a significance of 0.000, meaning that there is a significant difference between initiative participation between the two groups. All right, so the last part here is the survival function chart. And this is important because you can take a quick glance at this chart here without looking at any of the other data presented by the Kaplan-Meier test. And just by looking at the red and blue line here, the red line signifying people who did participate and the blue line indicating non-participation in the Healthy Hearts Initiative. So long as the red line is consistently above the blue line, we can say that at any point in time, the patients that participated in the Healthy Hearts Initiative had a longer or extended time to readmission than patients who did not participate in the Healthy Hearts Initiative here. So that was a quick overview of the Kaplan-Meier test. I have posted all of this information in the tutorial online on the Blackboard course for you. And as I mentioned before, if you have questions on other pieces of the assignment, take a look back at the prior couple weeks of our course here. And as I mentioned, we have already covered all of the pieces thus far. So that will be it for this week's recording here. One thing I do want to mention is that I will be posting later in the week some information on Tableau. We are wrapping up the statistics portion of our course here, and we'll be moving over to the data visualization piece of the course, where, you know, some people really enjoy the first half of the course and some people really enjoy the second half of the course. For anyone who felt like statistics really wasn't their thing, you know, we won't be doing too much more of this in the next couple weeks of the course until we really get to the end, you know, where you'll have to take some of your SPSS skills and some of your Tableau skills and combine both of them together for your final 2 assignments. So again, that is it for this week's recording. If anyone has any questions, please feel free to shoot me an email, and I will get back to you as soon as possible. Other than that, have a great week, and we will all talk soon.